This is problem 17 from the spring 2015 AMATYC Student Math Leagues contest. So this problem says the sum of the first n positive integers equals the sum of the 5 consecutive positive integers starting at a, and the sum of the 8 consecutive positive integers starting at b. Find a minus b for the least such a and b. Okay, so the first thing I'm going to do is just sort of parse what this is saying. So it says the sum of the first n positive integers equals, first bit is the sum of the 5 consecutive positive integers starting at a. So let's just sort of box that up. So we've got that. And it also equals the sum of the 8 consecutive positive integers starting at b. So kind of making a mess of this here as we go along. But we have sort of two sums that both equal the sum of the first n positive integers. So to attack this, what I'm going to do is I'm going to look at, first of all, the first n positive integers. That's 1 plus 2 plus 3 plus n. Now, you could write this in sigma notation. There's a formula for this. Let's just do both of those. So this is sigma notation, k equals 1 to n k. You might be able to look up a formula for this, or maybe you just know 1 plus 2 plus 3 up to n equals, the formula is n times n plus 1 over 2. Here. So that's our setup here. And that's just a formula that you could know, hopefully, previously. And we're going to say is this is the sum of the first of the 5 consecutive positive integers starting at a. So if we have a plus 1 plus a plus 2 plus the last one is going to be a plus 4. There should be 5 of them, but we started with a plus 0. If you look at this, you're going to get an a from each term. That'll give you 5a. And then you'll have plus 1 plus 2 plus 3 plus 4. Well, that's going to be 5a plus, well, we can, I guess, use this formula up here. It's going to be 4 times 5 over 2. That's 20 over 2. That's 10. So that's 5a plus 10. Now, the sum of the 8 consecutive positive integers starting at b, it's going to be b plus 1 plus b plus 2 plus and so forth. The last one will be b plus 7. Again, we pick up an 8th with just the b here. Well, we're going to get a b from each of the 8 terms. So that's 8b plus the 1 plus 2 plus 3 plus up to 7. So that's 8b. And we can use our formula again. Plus 7 times 7 plus 1 is 8 over 2. 8 over 2 is 4 times 7 is 28. This is 8b plus 28. Okay, so we get two equations here. We have n times n plus 1 over 2 has to be both 5a plus 10. And, well, we'll just write it here. It's 3 things that are all equal. I guess that's 2 equations, effectively. This also has to equal the 8b plus 28. So we have this sort of string of 3 things that are equal. Essentially, that is going to give us 2 equations, like these 2 equal, those 2 equal. But we have 3 unknowns. Seems like we don't have enough information. But it turns out that n, a, and b also have to be integers. So we're going to use that as well. So what I'm going to do, I'm going to take this sort of second equation, 5a plus 10 equals 8b plus 28. So I'm going to do that, and I'm going to solve for a. So let's maybe scroll up here. If I have 5a plus 10 is 8b plus 28, I'm going to solve for a. So I subtract the 10. Gives me 5a equals 8b plus 18. Divide by the 5. A is 8b plus 18 over 5. A is getting a bit sloppy there. Here. So I have an equation for a in terms of b. And now I can take n times n plus 1 over 2 equals 8b plus 28 and get an equation for n in terms of b. So I have n times n plus 1 over 2 equals 8b plus 28. This one's going to get a little bit uglier. So I took essentially the first part of this string of equations and the last expression. Set those equal. Let's see, this is going to be n times n plus 1 multiplying by the 2 gives me 16b plus 56. Get n squared plus n. And I've got a quadratic in n, so I'm going to subtract the 16b plus 56. Set equal to 0. And now I can use the quadratic formula. So that tells me that n, let me write this over here, is, okay, so negative b, a little confusing because of b already, but negative coefficient of n, that's negative 1, plus or minus the square root of the coefficient of n, that's 1 squared, minus 4 times, really, the coefficient of n squared, that's our a, normally in the quadratic formula, times c, which is the sort of constant term, that's actually a negative of 16b plus 56. Here, all over 2 times the coefficient of n squared, which is 1. So we get this formula here. I'm just going to simplify this a little bit. Negative 1. On the bottom we have 2. Now, we have plus or minus this square root. If you go back up to the beginning, we know n, some of the first n positive integers, n has to be positive. And so that means we better get a plus square root, otherwise we'll get a negative on top, positive on the bottom. Will give us a negative answer. So we know in this case we have to get the positive square root. 1 squared is 1. The negative and the negative cancel. I get plus 4. How about just times 16b plus 56? I'm just going to leave this like that here. Okay, so what I've got now is I have a given to me as a function of b, and I have n here given to me as a function of b as well. Now I need to figure out sort of values of a, b, and n that satisfy these equations, and everything's a positive integer. I don't know a nice short way to do that mathematically, but I can use my calculator to sort of streamline this. So what I'm going to do, I'm going to go to y equals on my graphing calculator. I have my first equation, that's a equals 8b plus 18 over 5. So I'm going to put in 8, use x for b. So 8x plus 18 is like the 8b plus 18. Divide by 5. So that gives me y1 is effectively a. y2, I'm going to put in this equation for n. So this is parentheses, so you got to do a negative 1 plus, whoops, didn't get my 1, plus the square root of 1 plus 4 times 16x. We're going to use x for b, plus 56. Close the parenthesis, close the square root, close the numerator, divide by 2. So I put those in. Now, I could just plug in different values here. The question is, how does this help me? I'm going to do this really quick by using the table. So if I go second, hit window, I get table set. Start at 0, delta is 1. And then I go to table, then, second, hit the graph key for table. So this tells me is when x, that's when b is 0, to satisfy this first equation, a, that was a equals 8b plus 18 over 5, a would have to be 3.6. So that clearly won't work. First of all, I guess b is not positive, it's 0. But a isn't an integer anyway. N works out to be 7, that's an integer, that's fine. 1, we get, let's see, positive b, positive integer n, but we don't get an integer for a. And so I'm just going to now scroll down until I find one that works. So I need all 3 columns to be integers, really the second 2, because the way I'm going through my x's, that forces them to be integers. So we go through, look, here's one where we have y1 is an integer, y2 is not an integer. Keep going through. We get another y1 integer, y2 not an integer. Keep going through another one of that setup. We get y1 but not y2. We go through, and let's see, we got y2 but not y1. Here we go. So we have, this is our lowest a, or lowest b that makes this work. And so what we end up with, let's see, this is b equals 34. A is 58. And n is apparently 24. So this should work as our solution. And now we need to go up and figure out what answer did they want. They wanted, a little bit hard to read now. Maybe I'll erase these things that I've drawn here. So we want to now find a minus b for the least such a and b. So we found the smallest a and b. Note a and b both go up here. So once we get the smallest a, that'll give us the smallest b as well. And we just need a minus b. So a was 58, b was 34. So a minus b is 58 minus 34. That works out to be 24. And that works out to be C, so our answer is C.